Right, so the first question says simplify the following. Right, we have got cos 180 degrees plus theta times cos 90 degrees minus theta divided by sine 90 plus theta times sine 180 degrees minus theta. So part A or 2A is the application of the reduction formula. So cos 180 degrees plus theta, I'm going to rewrite it. That will be cos 180 degrees plus theta times cos 90 degrees minus theta all over sine 90 degrees plus theta times sine 180 degrees minus theta. So I'm using the reduction formula that are there among those 12 together with these 4 here, and I might use the reduction of negative angles. So cos 180 degrees plus theta, it's in the third quadrant. It's equivalent to minus cos theta. So I'll replace that cos 180 degrees plus theta by minus cos theta times cos 90 minus theta. I'm sure you see that it's a co-ratio, so it's number 2 here. Cos 90 minus theta is equal to sine theta. All right? Then my denominator, I have sine 90 plus theta. Now 90 plus theta is in the second quadrant, so it's going to be equivalent to what? It's going to be equivalent to cos theta times sine 180 degrees minus theta is in the second quadrant. Okay, so it's equivalent to sine theta. Right. Now, generally, when we are marking the reduction formula, this is how the mark allocations are done. Every reduction, it will be 1 mark. Okay, every reduction, it will be 1 mark. So if you know your reduction, okay, in terms of this formula, you can get more marks, even if your final answer is incorrect. Usually these questions will have about at least 5 marks, most of them. So you can be able to get full marks or at least lose 1 mark. So it's 4 marks so far. Then the next step is the simplification now. Now to simplify this is just using your knowledge of algebra. Okay, so this sine theta and that sine theta are going to cancel out. Now take note here, there's a minus here. Okay, so that cos theta and that cos theta will cancel out. So you'll be left with a numerator which is equal to negative 1. So the final answer will be negative 1. Okay, so that final answer will be allocated a mark. So a question like this will have about 5 marks if it comes in a test or an examination. Okay, and this is how it is allocated. So use your reduction formula here, or you can use the co-ratios. In this case, we didn't have to use the reduction of negative angles or the fundamental identities. Right? So this is how we do the question. Right. In your dual control test, expect questions like this. Usually we'll just give you 1 question. Alright, any question? Okay, if you don't have any question, then let's move on to B. Right, B, we have sine 90 degrees minus theta times cos 180 degrees plus theta. This one is very simple, right? What sine 90 minus theta? Equal to cos theta. Times, what is cos 180 plus theta? It's here, it's in the third quadrant. It will be negative cos theta. So I can put that in brackets. Then you multiply that cos theta times the negative cos theta, you get your final answer as minus cos squared theta. And then you're done. Okay? Now here, the mark allocation can be given as follows: 1 mark here, 1 mark there, and the final answer 1 mark. So that will be about 3 marks for a question like that. Alright? Any question? So the basic idea is memorizing your reduction formula. I understand that it's new to you, so it will take you a bit of some time to get used to it. But it requires a bit of some effort, yes? No. The assignment tomorrow is on circle geometry. I told you that in time. The assignment for tomorrow is on circle geometry. That's why I gave you a worksheet last week on circle geometry. Remember, we just started. We only started last week on Wednesday. There was no school on Thursday, Friday. There is no way that we can test you on this tomorrow. Your assignment tomorrow, circle geometry from theorem 1 up to theorem 9. That's it. Okay? All right. Can I carry on?
Yes.
Right. The next example. Right. I took this example from Platinum Maths. Okay. The previous example was from my action series. Right. This one is from Platinum Maths. Now I want you to be aware that sometimes you can have reductions with X instead of theta. Okay. The concept is still the same. Right. Where we have got theta here, we can replace the theta by x as long as the x is acute. Okay, remember I told that for the reduction formula, our theta is an acute angle. Okay, now this question from Platinum Maths, which is one of the, this is our prescribed textbook in the school, they use x here instead of the theta. But the concept is still the same. You can have alpha as well there, you can have even beta and so on. But the concept of the reduction formula remains the same. So this question, the first part, right, I'm going to rewrite it. So it's sine 360 degrees minus x times tan 180 degrees minus x times cos 360 degrees minus x. This is all over sine 180 degrees minus x times sine 180 degrees plus x. Okay, so we are going to use the reduction formula that we have, okay, on your right here and on your left. Okay, so let's start with the first one. Sine 360 minus x is going to be like sine 360 minus theta. So it's going to be equal to sine x. Okay, so this is sine x times tan 180 minus. Oh, sorry, yes, negative sine x. Right? Then tan 180 minus x, okay, is going to be in the second quadrant. So it will look like this one here, which means it's going to be equivalent to minus tan x. So I'll put that minus tan x in brackets. Okay, then cos 360 minus x. Now this one is in the fourth quadrant. So it looks like this one here. So it's going to be equivalent to cos x. So that's all over. Now my denominator, I have sine 180 minus x, which is in the second quadrant. So this will be equal to sine x times sine 180 plus x, is in the third quadrant. So that's equal to minus sine x. Right? Now here, the mark allocation, it will be.
Sorry, is it not negative sine x?
For which one?
Then sine x is 8.
Sine 180 minus x, this angle here is in the second quadrant. In the second quadrant, sine is positive, so it becomes sine x. Okay? Remember your cast diagram from grade 10. Remember your cast diagram. This is the first quadrant, all three trig ratios are positive. Right? This is the second quadrant, only sine is positive. The third quadrant, only tan is positive. The fourth quadrant, only cos is positive. Okay, so in terms of mark allocation, this will be 1, 1, 1, you get 5 marks here in total. Okay, so the whole question probably might be 6 or 7 marks. Right, and 5 of them are just the use of reduction formula. Yes, Zach? Yeah.
The negative sign.
Okay, generally it's wise if the reduction is negative to put it in brackets. Okay, to avoid unnecessary silly mistakes. Alright? Then let's simplify now. Now I would suggest that you simplify starting with the numerator. or you can cancel out some terms. Okay, now as you can see, in the numerator and the denominator, we have got minus sine x. So this minus sine x and that minus sine x are going to cancel out. Okay, then I'm going to be left in the numerator with minus tan x times cos x. My denominator is going to be sine x. Now for this question here, we have to introduce the fundamental identity, this one here. See this one here? Tan theta equal to sine theta over what? Over cos theta. So what I'm going to do is I'm going to convert that tan, this tan x here, to sine over cos. So if I do that, I'll write this minus sine x over cos x times that cos x there. Okay, so all I've done is I've converted the tan x to sine x over cos x. Okay, using the first fundamental identity. Okay, then my denominator of that numerator is going to be sine x. Okay, so all I've done is, just to emphasize this part, is convert that minus tan x to minus sine x over cos x. Yes?
Because in that identity, and it's a negative term, why is it negative sine x instead of negative cos x?
Okay, I'm sure you can see here, Ronan, that this is minus tan x. Okay, it is the tan x that's negative based on the reduction from tan 180 minus x. So when we do the conversion using the fundamental identity, we don't touch the cos x. Okay, because it's already simplified. All we have to do is convert the tan to sine over cos using this fundamental identity.
I know that's what I'm asking now. It says negative sin x.
Yes, because here the tan x is negative.
Why is the negative of the sin and not the cos x? What are the denominator?
Okay, let's go back to fractions. It's a good question. Okay, it's a good question. The way that I wrote it here, okay, I put the minus in the numerator, but you need to be aware that if I give you a fraction like say minus 3 all over 2, this is the same as 3 divided by minus 2. Okay? It's also the same as minus 3 all over 2. It's the same. Because the result of this division has to be negative in the end. So whether you put the minus in the numerator or denominator, you still get the same result. Okay, but I would suggest, like in the way that I wrote it here, I'll make the numerator negative, or I can just remove this minus and put it somewhere there in line with the division line. Okay, so maybe I will do that to avoid unnecessary confusion, but make sure you're aware of that when it comes to the division. Okay, so I can take this out and put it somewhere else where it will be in line. So I can put it somewhere here, like that. Okay, it's do the same thing. So either I can make the numerator negative, or I can make the whole fraction negative like how I did here. I can make the denominator negative. The result will still be the same. Okay, alright. Any more questions? Okay, so from here now, the knowledge of algebra, okay, is required. The knowledge of algebra is required. So here, I'm going to forget about the division line. I'm going to simplify my numerator. If I simplify my numerator, I'm sure you can all agree with me that because of multiplication here, I can cancel out this cos x and that cos x because of multiplication. Okay? If there was addition here or subtraction, okay, or division, you can't cancel out. You only cancel out if there is multiplication. Okay? So, the next step, what this means is, I'm going to be left with minus sine x over 1, which is the same as minus sine x. So I can write this as minus sine x divided by that sine x. And the final answer will be negative 1. Okay. So the mark allocation already, we've allocated 5 marks here. The other mark will be given for using the fundamental identity. So another mark will be given here. Right? This is not necessary, so you get the marks there. So total will be about 7 marks for a question like this. Okay? Now, when you get a question like this one, at least try your best to get these 5 marks. Okay? Even if you, and also you get a mark for converting time to what? To sine over cos. You might have a problem with the final answer if it happens, but at least get about 5 marks for the whole question. Alright? Now, when you see these questions here, don't get scared. Okay? First, know your reduction formula and your algebra. Yes,
So if that 10 minutes was positive, then will
Then-
they make everything positive and the answer will be positive?
yes, definitely yes. If the tan was negative, was positive, then our final answer will be a positive one. Then this will be sin x over cos x, both will be positive, and here you have positive sin x both divided by positive cos x. Alright?
So
Yes.
if we didn't turn tan x into sine of a cos, we're still going to find the answer.
Yes. Alright. Let me show you. I'm going to study that. I'm going to do this question from this step here on the next page. Okay?
Let's get marks of conversion.
Well, generally you should get a mark for converting tan to sine over cos. But it's not everyone who do that conversion. But I encourage you to do the conversion. Because most provincial papers and the national papers, they allocate a mark for the conversion from tan to sine over cos. So that's what I encourage, but it's not the only way of doing it though. Okay? We could do it this way. I'm going to start from that step. Okay, I'm just doing this for you to say, alright? So we could say minus sine x times minus tan x times cos x. This is all over sine x times. So here we have got minus sine x. Right. Let's say you don't want to convert the tan x to cos to sine over cos. So you could have a scenario like this, whereby these two cancel out. Okay. Then you end up having minus tan x times cos x all over sine x, like that. Then we bring in now knowledge of algebra. Your algebra is very important. That's the foundation of trig. So this becomes minus tan x times cos x over sine x, like that. Okay. Why do you have to do this? Because there's multiplication in the numerator. Okay. Now, do you agree with me that if sine x is equal to sine x over cos x from the fundamental identity, okay, it means the denominator of that tan is a what? It's a 1. So here, the cos is on top. The sine is what? Is the denominator. So I can just swap these two, swap those two, so I have 1 over tan x is equal to cos x over sine x. Then I'll plug that 1 over tan x there. So I'll get minus tan x times 1 over tan x. This cancel, and you get negative 1, which will be the same result.
So
Yes.
you see for the negative sign, you say negative sine x divided by negative sine x. We're only allowed to divide the negative. It is like negative sine by negative sine and negative.
It's always better to divide a negative in a negative than a negative in a positive. It's always
Like,
better that way.
what I'm asking then is negative sine x, you cannot take the minus away by the negative sine x. It has to be 10 divided by 10, the sine divided by sine.
Are you talking about here?
So look at the whole equation. You say
And I'm talking about this. Are you talking about this step here in red?
yes, I'm asking, you say negative sine x
Yes.
divided by negative sine x.
Yeah, but do you know why I did that?
Yes, I know that. What I'm asking is that are you only allowed to divide by negative? If it's like the same, like negative
If
sine
they are,
negative
yes,
sine will.
if they are identical terms
Oh,
and they are both negative, then you cancel those out. The objective is to minimize the existence of negative signs.
so
We
what
don't
if,
want too many negative signs.
what if I say negative sine x over negative sine x? Don't like the negatives go away.
Yeah, it's too correct as well. It's too correct.
Oh,
Okay? If you decide to do it that way, it's fine. you cancel out that negative and that negative, then you're left with 1 there. It means when you write this tan x here, it becomes positive here. But the whole expression now becomes negative. So it's fine. Are you following them? Huh? Alright. Okay, let's move on to the next one. Okay, that's the next one there. Then I'm going to give you your own class exercise. Alright, so we are still carrying on with the use of the reduction formula. But this one now is slightly more complex. Okay, slightly more complex because we have got that x minus 360 and that x minus 180. Okay, well, so before I carry on, I just want you to be aware that sine x minus 360 degrees, I can simplify this. But if I were to ask you from what you understand about quadrants so far, in which quadrant is x minus 360?
4.
No.
X minus 360 equals negative cos.
4, so
It's in which quadrant?
4.
Please don't confuse 360 minus x and x minus 360.
So it's the first one.
It will be the first quadrant. Thank you. Okay? Alright. How do you know that it's in the first quadrant? Right. The best way, you can just add 360 here. You add 360, you eliminate the minus 360. And you end up getting sine x. Okay? That's one way of doing it. Alright? So this is the same as sine. You can write this as sine, open bracket, minus 360 degrees. Okay? Plus x. Okay, I'm taking you to the basics. Plus x. Alright? Then I can write this as sine minus open bracket 360 degrees minus x. I'm using my knowledge of factorization. Right? You following what I'm doing? Right? Then because of this minus here, I can write this minus sine 360 degrees minus x. But what is sine 360 minus x? You get minus open bracket. Based on what we have there, this angle 360 minus x is going to be in the fourth quadrant. And in the fourth quadrant, sine is negative. So in the end, the final answer will be 5x. So it's more like you're saying, we are in the first quadrant. That's what this x represents. Then we move 360 degrees clockwise. We'll come back to the same one, to the same point. Do you understand what I'm saying?
So we can come down.
Yes. Okay. Remember what I said yesterday. Negative angles are measured in a clockwise direction from the x-axis. Positive angles from the x-axis in an anti-clockwise direction. So, angle x, which is positive, is in the first quadrant. So if you move minus 360 degrees from this point where x is in a clockwise direction, you come back to x. Are you following what I'm trying to say? Okay, let me draw a sketch for you what I mean. X is like this. This is x. Alright? So, we are here. Here, this point here, if you move 360 degrees, if you move 360 degrees in that direction, you will come back to the same point. Minus 360 degrees means it's one revolution in a clockwise direction. If you think you can get confused with that, then the only route is the mathematical explanation. Okay?
So theta minus 360 in the first quadrant.
Yes.
Theta minus 180.
Right. Then let's do sine x minus 180 degrees. This one here, this angle x here, it's in the first quadrant. You move 180 degrees in a clockwise direction. You are in the first quadrant, okay? You move 180 degrees in a clockwise direction, you end up getting to the third quadrant. Okay? But let's prove that this is equal to minus sine x. So this is the same as saying sine minus 180 degrees plus x. And this is the same as saying sine, open bracket, okay, let me put the square bracket. So it will be square bracket minus 180 degrees minus x, like this. Following that, then we use our knowledge of negative angles, which is here, sine minus theta. So this will become minus sine 180 degrees minus x. What is sine 180 minus x? It's going to be equal to sine x. Because of this minus here, you get minus sine x. Okay? So your knowledge of quadrants, negative angles is required, yes.
This is a bit more.
Can you come again?
The working out that you just did now, that will be more.
No. But you see, remember, I'm a teacher, so I need to show you that sine x minus 360 is equivalent to sine x. Also to show you that sine x minus 180 is equal to minus sine x. I haven't started doing the question. I was just trying to explain to you how we are going to get the reduction of these two.
So what I do is I just swap them around and time to time. In my head, that's what I do.
So,
Alright, okay, well, let me do the question we have there.
And I'm saying in my head, that's what I do.
Okay, let me do the question we have.
so for the ratios, whenever it's theta minus 360, it's in the first quadrant. So all the ratios are going to be positive exponentially.
Theta minus 360, yes, is in the first
So
quadrant.
all the ratios are positive.
Yes. Okay, let's do that question. So it's sine 180 plus x, sine 180 degrees plus x times cos negative x, right? Yeah? Over tan minus x times, there's a plus here, sine x minus 360 times x minus 180. Right? Now check this out. Because we've got this plus here, you have to be very careful how you carry on because of that plus. You have to be very, very careful how you carry on from this. Okay? So sine 180 plus x, that's equivalent to minus sine x. Okay? You see, this angle here is in the third part. Right? Then cos minus x is equal to cos x. Okay? Positive cos x. So this will be cos x all over. Tan minus x, that's minus tan x times. Like we have already determined that sine x minus 360 is equal to, so there's a plus here, sine x, right, times sine x minus 180, that's equal to minus sine x. Yes, do you have a question?
So cos minus x isn't equal to minus cos x.
No. I explained to you the reason why it's positive cos x. In each quadrant is minus x. Fourth. Cos is positive in the fourth quadrant. Then, yes, on the, you cast that. You cast that. In the fourth quadrant, cos is positive.
But for the reduction formula of minus theta, cos and we do that with minus theta.
So you got to cos theta. No. Then you didn't copy the doctor. Please take note, cos minus x is equal to cos x. Okay? Please take note of that. Cos minus x is equal to cos x. Because minus x it's in the fourth quadrant. In the fourth quadrant, cos is positive. Okay, it's very easy to make a silly mistake there. Right, from here now, right, my suggestion, convert this minus tan x to sine over what? Over cos. Fortunately, these two negatives can cancel out. Right? Because we don't want to work with too many negatives. So we end up having sine x times cos x, right? All over sine x over cos x plus, in actual fact, sine x times minus sine x will give you a negative sine squared x. Right? This sign here we're going to change from being positive to what? To negative. Do you see that? Huh? Okay, but here I'm just simplifying. Sine x times minus sine x gives you negative sine x. Alright, let me get on to the next step. The next step is to simplify this part. Okay? To simplify it, I would suggest that we write it this way: sine x times cos x divided by, okay, I'm changing the division line to a division sign, so that will be sine x over cos x minus sine squared x. So this positive sign changes to negative. Yes.
For the denominator is negative, the numerator is 1/8 over cos x.
You see what I did here? I crossed them out.
So just even if it's a sin x and a tan x,
You can,
still cancel.
yeah, if both are negative, you can cancel them out. Right, we are here now. The next thing that we need to be aware of, the denominator here is what? 1. Then we need to convert this division sign here to a multiplication sign, then we invert those two. Alright? So if we do that, we end up having sine x over sine x times cos x, right, over 1 times cos x over sine x minus sine squared x. Then this sine x cancels with that sine x. You see that? And then we are going to end up having cos x times cos x, which is cos squared x. So this will become cos squared x minus sine squared x. Right. This is an identity itself from grade 12, but you are in grade 11 now. Yes?
Why did you just cancel the cos x before you convert it to multiply?
Cancel where?
Cos x.
No, you can't cancel here because there is division.
So what would you turn it to multiplication?
Yeah, I did. That's what I did. But you can't do a cancellation once there's division. Well, we can simplify this. Okay, either we can write, can I have your attention? We can write our answer, we can leave our answer like this, or we can simplify it and write it in terms of sine only or cos only. I remember what I told you yesterday, that this identity can be written as sine squared theta is equal to 1 minus cos squared theta. Right? It can also be written as cos squared theta is equal to 1 minus sine squared theta. But for now, I'm going to leave the answer like that. Right? Allow me to leave the answer like that. There is no need to simplify, so we'll leave it like that. If there was a plus here, then the answer would be what? 1. But there is a minus. And this is a grade 12 identity. Okay? It's called the compound angle. We'll talk about that next year. Right? So we'll stop there. Okay? Yes.
Do you have the daily notices?